11.5 is about graphing linear inequalities. So in our last section, we learned about graphing lines. So once we know how to graph a line, there's not a whole lot more to know about graphing a linear inequality. We want to start by having our inequality in slope-intercept form, y equals mx plus b. The only difference is now instead of an equal sign, we have an inequality symbol. Okay, and we've learned about, I think we learned about inequalities before at some point. So you've got greater than or equal to, less than or equal to. So if it's an or equal to, that's an inclusive inequality, you're going to draw the line as a solid line. Otherwise, you're going to draw it as a dashed line. So here, the points that are on the line are included in the solution, and these are, in this case, the points on the line are not included in the solution. Yeah, we did this before. It's just like, the difference between a solid dot versus an open circle, a square bracket versus a parentheses, okay? And then as long as you've got it in slope-intercept form with a y on the left side, then you can just shade above or below, okay? If it's greater than, shade above. If it's less than, shade below. Now, to me, that's the easiest way to figure out where to do the shading. But there is another way that they talk about on the MyLabs Plus if you view their examples. And I can talk about that as well when I'm doing the example. So number one, we've got it basically in slope-intercept form. And so we can see that the slope is -3 and the y-intercept is 1. All right, so we're just graphing the line like we would normally. First I'm going to plot a point at the y-intercept at 1. And then the slope is -3. So from there, I'm just going to go down 3 over 1. All right, and I can also go up 3 into the left 1. All right, and this is greater than or equal to, which means I'm going to do a solid line. All right, and then it's greater than, which means I'm going to shade above the line. Okay, so it's like if this line was a ladder or a staircase, I'm climbing on the ladder. Okay, that's the side that I'm going to shade. So this whole side of the graph over here. A lot faster just doing it on the computer with a little fill tool. Okay. All right, so that's basically it. Now, another way to figure out which side you're going to shade is basically just by picking a point that is not on the line. And I always like to pick 0, 0 if I can. And then you plug that into the inequality and see if it's true or false. All right, if it's true, you shade the side that has that point on it. Otherwise, you shade the opposite side. All right, so like here is 0, 0. X is 0, y is 0. So if I plug in 0 for x and 0 for y into my inequality, that would say 0 is greater than or equal to -3 times 0 plus 1. So that would, if I simplify that, that would be 0 is greater than or equal to 1. All right, so is that true or false? Well, obviously that's false. So that means do not shade the side of the line that contains that point. Instead, shade the opposite side, all right, which is what we already did. All right, but that's just another way of figuring out which side you need to shade. All right. So number 2, again, that is in slope-intercept form. I can see that my y-intercept is -3, and my slope is 1/2. So from that point, I'll go up 1/2. I'll do that a few times. And in this case, it's strictly less than, not equal to. So I would use a dashed line to graph it. Okay, and it's less than, so I would shade below the line. Okie dokie. Easy peasy. All right, number 3. So in this case, it is not in slope-intercept form. So first I want to get it into slope-intercept form. So I want to get y by itself. So I'll start by subtracting 3x from both sides. So that gives me 2y is less than or equal to -3x minus 6. And then I'll just divide both sides by 2. So let's just divide each term by 2. So that would give me y is less than or equal to -3/2 x minus 3. So I can see that my y-intercept is at -3. And my slope is -3/2, so I'll go down 3/2 from there. All right, and then I can also go up 3 and left 2. All right, and this is less than or equal to, so I can use a solid line. All right, and it's less than, which means I'm going to shade below the line. Alrighty. Alright, number 4. Alright, so again we have, this is not in slope-intercept form, so I'm going to start by getting it in slope-intercept form, which means I need to subtract 3x from both sides, which would give me -y is greater than -3x plus 4. All right, so -y is the same thing as -1y. So I'll go ahead and divide both sides by -1. So I can just divide each term by -1. All right, and so now remember, when you divide by a negative, you have to flip the inequality. So I'm going to flip this. So instead of greater than, now it's going to be less than. So y is less than 3x minus 4. All righty, let's see here. So I can see that the y-intercept is -4. And then the slope is 3, so I can go up 3 over 1. Do that some more. Alrighty, let's see. Now it is strictly less than, not less than or equal to, so I'm going to use a dashed line here. Okay, and then I'm going to shade. It's less than, so I'm going to shade below the line. Alrighty. Number 5. Okay, so x is greater than -3. So that's going to be a vertical line. Okay, let's see here. Vertical line at -3. And it's strictly greater than, not greater than or equal to, so that's going to be a dashed line. All right, x is greater than. Okay, so in this case, above or below doesn't quite apply, but it is going to be the side that has x values that are greater than -3, so that would be the right side. So all of the side over here. Alrighty. Okay. So let's see. Now let's kind of go the reverse, and we will look at the graph and figure out the inequality from that. All right, let's see. So just like with any line, the first thing I want to do is locate the y-intercept. So in this case, that's wherever it crosses the y-axis. So that's right here at -1. So there's my y-intercept. So b equals -1. All right, and then let's find another point on the graph that looks like it's easily identifiable. So how about right there? Okay, then I'm just going to count, always going from left to right, of how do I have to go to get from this point to this point. All right, well, I have to go up 1, 2, 3, 4, and over 2. So I have to go up 4 and over 2. So that means that m equals 4 over 2, which reduces to 2. So m is 2. So then I just want to plug that into my y equals mx plus b, except for it's not equals this time, it's an inequality. So that is gonna, all right, so it's gonna be 2x minus 1. All right, now this is a dashed line, so it's not gonna be or equal to, and the shading is below the line, so that's gonna be less than. All right, less than, but not equal to. All right, so y is less than 2x minus 1 would be my answer. All right, same thing here. First, let's find the y-intercept, which is at -1. Again, so b is -1. Let's find another point like right here. All right, now going from left to right, I have to go down 2 and over 3. So that means that m equals -2 over 3. Okay, so it's going to be -2/3 x minus 1. All right, now the shading is above the line, so that's going to be greater than. And in this case, it's a solid line, which means it's or equal to. So y is greater than or equal to -2/3 x minus 1. All right. And that's all for section 11.5.